So I had some time. I just woke up, and I have about a little over an hour or so before I have to go to work and stuff. So I figured, and I wanted to continue working on Matcha Client, so I figured, why not? We're going to continue with the protocol. So the plan, so last night we wrote all the reader and the writer slash buffer. And we're going to work on the actual packets themselves. So I found this yesterday, which is just a collection of all the protocol data. So we need to figure out how to turn this into actual protocol packets. And that's kind of the goal. So, because I don't want to do this all by hand. I could, where is it? We could use this and go by hand every single one. Actually, that might not even be a bad idea. We could do every single one. The other thought I had was you could actually use the Minecraft jar itself, and you can do some manipulation of it there to be able to generate the packets for Rust. But I think, what is this packet? This is update sign. Let's see if this is actually... Okay, so we have packet sign. Okay, so that's fine. And let's look at packet map. We have item damage, it's a variant, we have scale, it's a byte, icon count. This is an array, byte, 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 so that looks good. I'm more worried about how they've done these optional fields to switch compared to columns. I see. Okay. Interesting. Very interesting. So we need to figure out, this is, I think, going to be like Python, I'm kind of feeling. Figuring out how to turn this giant thing into packets and packet readers for each thing. So, hold on. I don't know why my YouTube output on the stream has like bars on the sides. Thought I figured this out already. Well, I think it's okay for now. So that's kind of the plan. We gotta figure this out. I think this is probably going to take longer than just this morning. So this really does capture all the packets though, which is really cool. Let's see. Or maybe there's a tool that can actually read this for us. So we could do this realistically, or I feel like I kind of want to implement the packets myself. I feel like this is a lot for right now. Yeah, I think for right now, we're just going to implement the packets ourselves, do it by hand, and we'll figure out the rest later. So I guess let's get to work. So I'm kind of thinking we'll just do like a play, or like play packets, and we'll just have this on the side, and move this into here. And we'll just do that. Actually, we're going to be doing status first, not play. Okay, let's see. I was also kind of thinking we could do the chunk reader, because the reason why is that where was it? I swear it was right here. Yeah, right here. I feel like we do the chunk reader or NBT stuff as well, because I want to have all the protocol done, and if we do the chunk reader, that's going to come in handy later. Same thing with NBT. I don't want to bore, but I don't want to. Just writing out each packet is going to be a little boring. So you know what? I think that's what we'll do instead. I think that's a better use. So how should we organize this? Well, let's first find like how we would implement this. So and I'm kind of thinking we're going to have to look on the web archive to find this. Alright, here we go. Chunk format. And let's just go back to like the protocol. Then we're gonna need to find the time. This should be like recent Minecraft, not, yeah, 1.20.4. Oops, wait, I don't want to do that. Let me just do this. Let's go back to like 2016 and This should be fine. We just had to see in Minecraft. And Summer nights 15. Wow, that's a quick turnaround. No way that's true. Okay. Let's do January. I mean, yeah, January. Okay. So, oh wait, this might be a better thing to look at. Yeah, let's do this. The reason why I'm on Web Archive for this, by the way, is because this website actually shut down. They moved it, or they merged it into the Minecraft wiki, and I find that some of the content that was on here didn't really get merged over well to the Minecraft wiki. So, wait, this is not helpful. I want the, no, wait. This is not helpful either. Oops. This is probably not going to be helpful either. Oh, wait. Yes, this is helpful. Chunk format. Oof, gone. Erased in time. Okay, so this is, I think, what we want. So, I guess we can have a chunk.rs. And so, say struct chunk. It's to be public. I think I might move these into the same thing. I don't know why I have them as separate crates. Okay, so we have chunk, storage, chunk data, and array, either this or this many bytes. Chunk is a wonderful manual arrays. Okay. Chunk column, 16 chunks aligned vertically. Okay. So we can make a chunk column. Or let's see how we want to organize this later. World is a collection of chunk columns, fine. For chunk. I kind of want to call this a partial chunk because this I feel like everyone thinks a chunk is like 16 by 16, which it really is. So we're going to call this a partial chunk, I think. And we're going to have... The problem here is I don't know how large this should be. So for now we'll call this, I guess, chunk data. And I don't know how large. We'll just do that for now. Except I thought it would give me a sizing error. And how do they organize this? This is 126. This is 16 by 16 by 16. 196. How do I get all that into one multiple chunk data arrays? Okay, fine. So I wonder, can we do like a type chunk data equals? Okay, I think I see how this is going to work. So bitmask, sometimes we get a blob of data in a bitmask. Each bit in the 16-bit short represents a chunk. Okay, the least significant bit determines the chunk problem. This and so forth. If it's 0, the chunk is entirely air and there's no data to be read. So let's add this, I guess, chunk column. Chunk X. I'm going to call this chunk X explicitly this way because I might get confused with if it's just X and Y later. That it's a X and Y, not rounded by or divided by 16, really. It's giving me a U16, right? Since this was a short. Bottom of the top, okay. Blocks are ordered Y, Z, X. Okay. So basically they go, yeah, from bottom to top, basically. So this is not at all what I thought it would be. I thought we'd get a little bit more explanation here than we did. So I guess we have to look at the protocol. But I guess this is what happened. So let's see. Let's go back. Where's the protocol? Yeah. Let's click this. Let's see what it will tell us. Should be the same thing as the Minecraft guide, except the links should work. taking its time. Here we go. Yeah, see, this is the code I was talking about, which we implemented ourselves yesterday. But they used to have that, and then it's gone now. Probably because everyone was stealing it. Okay, this is a much better explanation. Look at this. Let's give this a read. I guess this is a good way to, or chunk section. This might be too new. Okay, I don't know if that's really helpful right yet. Oh, we need to do NVT as well. It seems like NVT might depend on this more. This is useful. Um, okay, so how are they doing the height map? Good question. Yeah, so this isn't the new format. We need to find the old format. Let's research this up. So here's what we'll do. We'll say, um, we're going to delete this, and we're going to go back here, and we're going to implement a reader for read chunk. Or this would really be I don't understand why this isn't appearing. I thought this is how traits were supposed to work. No? I guess. This is just how it is. Maybe it's the ID. Probably is. Oh, I don't like how we did this already. We're just gonna do this. Or I just want it to be like an easy, like, oh boy. Is this not how you do it? Oh, I swapped the order, that's why. Okay, cool. Now, what I wish I could do is like, you know what? This is what we need. Yes, this is what we wanted all along. Duh. And we do want it to own, potentially. We'll save that decision for later. If we want it to own it. Alright, cool. That's on X. And this is going to be an anyhow result void. Is that a thing? No, it'd be this, yes. This is the wrong thing. Awesome. Look at that. That's clean. That's clean as blank. So let's do the writer. Whoops. Figured. Have to do that. Alright, cool. So now we have a to-do, read packet, sorry, read chunk. And this is going to go up here. To write chunk. So again, we're back to where we started, which is I have no idea how chunks are sent. So we've got to figure it out. Go back to like 2017, because that's all we got. Or, you know what, we can probably look at the version history of this document. Two. I don't want to reference that really. I mean, I guess the other thing I want is like, let's just maybe define the API I want, and then we'll like read it into it. So I want I want to be able to I want get block. Well, we'll leave it as that for now. This is actually kind of not relevant because we haven't even read it. We don't even know what data we're getting. half byte arrays. I don't even know what this means. Okay, so it's, I mean, I guess, but like, you know what? This is like way too much. Too high cortisol. We're just gonna look at the implementation, I think. In Java. Or actually, no, we probably could look at in here, the actual game. So what is it? Chunk 21. Okay, this might be something. I see. All right. See, I guess we don't want to use that. I want to use the actual. I want to make this hard on myself. This is, again, this is about learning. So, what we're going to do is we're going to do chunk data buffer equals sudo flip that size. Can we do that? No, we need a vec. And maybe we'll change this later so we don't need we don't need to allocate it on the heap and at runtime and so on and so forth. View size. Cool. So now we want to do you know, we can probably add this to the reader. I think that's probably the right way to do it. Read, back to array. Nice. Okay. This is interesting. What exactly is going on there? Because you know what? This doesn't look like a varant to me. This looks like a U16. No, it's just a regular short, I guess. A signed short. This is weird. Alright, so let's go back. This is actually more helpful than the actual thing. So
shadows disappeared, the animals inside came out to play. Went face to face.
So weird. So this is looking to me like a get array size function type thing. Kind of that's what it's looking like to me. This is the if statement I'm struggling with here. I'm trying to figure out what this means. Because it has to receive the thing somehow. Right? So like, where's the packet registry? That's not what we want. I want net handler play client. Where's this? Why did I not see it? Because it's in here. Okay. Jeez, this is crazy. I bet you there's a handle chunk data. Yep. Yeah, again, I just don't know how we're getting this. If it's never, or if it's not. Okay. Yeah, I just don't know how this is working. I'm assuming this is coming from, or I don't know how it's making this check. If it's not equal to null, and I don't even know what the, I don't even know. True. False. So is glowstone actually potentially more helpful? And I bet you this still exists. Yep. Skylight entire chunk section fit mask. So this would be skylight here. And this is probably the bit mask. Yeah, this is definitely the bit mask. So okay, so maybe we can do something with that. Oh, so wait, that would make sense because if this one is the entire chunk, most likely. So if it's not the entire chunk, or this chunk section is or it's not empty, and we have this here, then it's going to read it. That's what it's saying. So if we can start with this, I think. If the bit mask and this if it is not equal to 1, not equal to 0, and so this is bitmap, or does bitmask include chunk? Perfect. So that's the first condition right here. And then somehow, I don't know how we're going to pass this in, but we need to know if it's going to be the entire chunk or not. I guess we just have to put it here, right? This entire chunk. Cool, and then this skylight. And then I'm going to say if self dot I think we can skip this for now. This is alright to skip. So if it's not the entire chunk, or this is not empty, I don't feel like we need to worry about this. I don't know why. Or we can probably just, I would rather do this. I just don't get all this setup, or you know what, this is two messages, I'm not deserializing it. Ooh, this is not helpful. Let's see. Not too keen on this. Can't lie. Let's just do the simpler ones now. I think we can take a break on this and come back to it later. Or in the meantime, we can implement NBT. That's probably a better use of time. Now, I remember the NBT documentation for this is actually not bad. So let's see how I want to do this. I don't actually remember the format of this very well. It's been a year at least since I last touched this. Individual part. The first byte is the ID. Okay. Tag. I don't understand why I can't do this. This is a 2 byte thingy. This is gonna be an AI quick fix right here, because I'm not gonna. This is just a Rust thing. I just don't know yet. Okay, so I guess you just have to do that. Name length, and then the name is in UTF-8 format. Okay. Okay. Pretty self-explanatory stuff here. So just be return that. Return actually we'll come back to this, but 0x01. But for everybody else, or we can say if tag type equals 0, return there, and then otherwise do this, read the name, and then otherwise we'll have a match. And this is going to be read a byte. Why does this think it's going to be an unreachable statement? It's not always going to be that. We'll just put error or to do. Whatever. So now we want like a read byte. And then we're gonna read short. Or no, we don't. We can just do this. T tag. We want name. This is heap allocated, so we want it to be a capital string. Tag, tag, type, then and byte, float, little white array. String list compound. Array. Long array. Now we can do tag type. The name, and then we're going to have a value. And what I've done in the past when I've made readers for this is, I don't know how we would do this in Rust. Maybe we can, or we probably can't. But what I've done in the past is I've just had you can have this as a vector of bytes, just like a data buffer, right? Yeah, that's what we're gonna do. So we're gonna do this. And we'll have this be optional. So it might not be a data buffer. And this is also optional. But that would make it annoying, actually. And so would this. So we're gonna do OK. Tag.
Here we go. Invincible.
This is nice. You would not be able to do this in C the way you can here. So props to Rust for this. Oh, I see. So I guess I can't. So we can implement this, though. It's not a big deal. And I'm just going to have AI complete this. And this will actually let us remove this if statement here. Should not be taking this long at all. I'm sorry. We're going to do it the old-fashioned way. It's probably like writing the entire rest of the parser for us. But that's not what I want. It's not what we're here for. Rats. That's annoying. Well, you can do this. It's okay. Alright, and then we need a error. Valid tag ID. Nice. So now we can do. I can do this. Perfect. That's really clean. Can't lie. Now we have the tag type, the name. No, we don't. Not yet. Name buffer. String. UTF-8, because we said it's encoded in UTF-8. Name buffer. Boom. Value. Right, and that is our data buffer. So now we need to read the value, or we need the length. Actually, what do we need? Let me think. I don't know. I think I'm gonna end it here. We've been doing this for like an hour and a half, and I gotta get ready for work. So I'm gonna end it here.